Welcome! This is a tutorial on the basic camera controls and how your camera works. So let's get started. Okay, just a little background on how the camera started and how it came to be. The principle of all modern cameras is based on the camera obscura, which is basically a light-tight box. And we can credit, or most people credit, Leonardo da Vinci with the invention of the camera obscura, which was a tool used by artists to trace and get their landscapes or their perspectives correct. So a light tight box or a camera obscura, the basic principle is a tiny pinhole. So sometimes you'll hear the concept of a pinhole camera inside any light tight container. So it could be a can or a box where no light can get in, and then there's a tiny hole on one side where light can come through, and the image that's outside of that box or camera is projected on the inside upside down. So in my class, I've had students in the past create pinhole cameras out of any materials, cans, containers, coffee cans, boxes, shoe boxes, Pringles cans even, out of materials like tin foil or aluminum foil, and a tiny pinhole and spray paint, and then it can actually record images that way. So that's a basic history to the pinhole or the camera obscura. So the modern camera that we use has four basic parts that we're going to look at today: the body of the camera, the shutter, the lens, and the aperture. So we're keeping it very simple. I found this very simple diagram. The body, which is the light tight container, the shutter, which is located inside the body of the camera, the lens, which is outside. Sometimes it's located real flush with the camera, depending on what camera you have, and the aperture, which is a hole inside the lens. So let's look at each of those parts a little more in depth. The camera body, I found several images to demonstrate. Most of these camera bodies don't have the lenses attached, but the camera body is the box or the part that you would hold. The lenses sometimes come off, sometimes are fixed, that you can't detach. So these are all different camera bodies. They can be giant and heavy, or they can be really small and compact. The shutter, the next part that we'll look at, the shutter in a film camera, that's an old-fashioned type camera that most of you probably have never seen. The shutter in a film camera is most like a curtain. That's the best way to describe it. In a film camera, the back of the camera actually opens up, if you've ever seen one of these, and it's actually like a little curtain. Sometimes they are actually made out of fabric, which opens and closes for a set amount of time. The shutter is a time control. The shutter controls how much light enters the camera for a set amount of time. The shutter can actually also be little like aluminum slats. Think of like a blinds on your windows that can open and close, but they would open and close really quickly for a set amount of time. In a digital camera, the shutter is also located right inside the camera, usually right behind the lens, and this is what a digital camera shutter looks like. The shutter is controlled by the shutter speed. The shutter speed on a film camera, this is an old-fashioned control. These are the shutter speed controls. They're in fractions of a second. So these numbers that you see are fractions of a second. So the 1000 would be 1/1000th of a second. The 500 is 1/500th of a second. So if you come all the way down to the 1, so 1 over 1 is actually 1 second. 2 would be 1/2 of a second. The B setting is actually standing for bulb setting. That means that if you set your camera on the B setting, bulb setting, that it will stay open. The shutter will stay open as long as you keep that shutter button down. Bulb setting is for very long exposures. That would be used for nighttime or for certain times that you would want to have a long exposure, which I'll show you what that means. On a digital camera, which most of you will be using, this is the different controls that you would find for shutter. In your digital screen, it would look something like this. This is 1000. You would look for this kind of number. This is a 45. 125, which is a more common setting. If you have a dial setting, you're going to look for something like the S, which stands for shutter. Shutter, and on Canon, and I think at Pentax also, you would look for TV, which stands for time value. So that TV setting, which you can override the automatic, which should stand for TV, so you can have shutter priority on those settings. That's the controls you'll look for. So why would you want to play with your shutter control? In certain situations, the length of your shutter will control the way that your photograph looks. In low light settings, you want to have a longer shutter. You want to let more light into your camera so that you can have more light in low light settings. This is an example of a nighttime or dusk. So you would have to, in this sort of photograph, this series of photographs, you would have to have a tripod or an image or something stable to set your camera on so it's not blurry. For long exposures, you need to have stability. That's when you see photographers with a tripod, because you cannot have a long shutter. It's over 1/60th of a second without having camera blur. Most people cannot stand perfectly still. You can see a little blur right there. Also, motion control is controlled by the shutter. So we will be doing projects shortly that deal with motion control. So I have a little chart up here that I found that shows you the difference on the different settings for your shutter speed. This is considered a fast shutter. 1000 is a fast shutter. You would use this for action shots, for frozen motion. Frozen, and then it starts to get blurry the slower your shutter gets. So this would be intentional blur when you get down here to a half of a second. That would be very slow. So you would use slow settings not only for low light, but also to blur motion. You would use fast settings for bright light, but also to freeze motion. So this is an example of frozen motion photos. These are student photographs, which I think are great. So these are frozen motion. You can see that the images are clear and crisp. The subject is moving, and the motion is mostly, you can see a little bit of blur here and there, mostly frozen. So these are probably down here. Here's some example of blurred motion photographs. These would be down here on the lower end of the scale. So in low light, so this is not only low light, but also blurred motion. So low light and blurred motion. You can have bright light and blurred motion, but you would have to make sure that you are controlling your exposure, which we'll get into when we get into those assignments. So there's some examples of when you would want to have blurred motion. So when you see the images of traffic with the lights streaming by, this is how you do it. You do it with a slow shutter speed. Okay, let's move on to the next control, which is lens. The next part of the camera, which is the lens. Lens type. Some cameras are a fixed lens. That means that the lens does not come off your camera. It's called a point and shoot camera. These are examples down here of point and shoot cameras. There's all kinds of them. Most people that are shooting with their cell phone, that's a point and shoot camera. Your cell phone becomes a point and shoot camera because your lens does not come on and off. You cannot interchange it. When we talk about interchangeable lenses, it's called an SLR or a DSLR. And SLR is the old type film camera where you take film in and out of your camera. Again, most of you have probably never seen one of these or used them. Some of you may have. Those of you that are older, like me, we use these all the time. DSLR stands for the same type of camera but a digital version, and this is what most of you are familiar with. It uses a memory card, and you take this card in and out, or you can plug in with a cord into your computer and download the images onto your computer. This is what most of you are using. These type of cameras are these for the class. So these cameras here have lenses that can come on and off. These cameras here, the lenses are fixed. You cannot take the lenses on and off. Okay, but they still all have lenses. Okay, here's some examples of the lenses that are interchangeable. You can have lenses that are fixed or lenses that are telephoto, which means that you can zoom in and out. Or I'm sorry, zoom lens, which means that you can zoom in and out of different sizes. A telephoto would be a close-up. We can zoom in. Wide angle shows you a bigger angle of view. Standard would be more what mimics your eye, which we'll get more into that when we talk about lenses later in the semester. The aperture is located inside the lens. This is the last part of the camera that we'll discuss. The aperture is actually a hole inside the lens of your camera. This hole inside the lens of your camera can be adjusted to let light in. You can let in more or less light. So all of these parts of your camera work together to balance out, and that's called exposure. So we'll learn more about how to control all the different exposures, and the way that you control all your different settings has an impact on how your image looks. Let's look again. This is your aperture inside your lens. This would be considered a large aperture. So if we adjusted this to a very large hole, this would be a large aperture. Here's medium and here's small. This is right here adjusted to a smaller size aperture right here. This again controls how much. This would be a lot of light coming in with an f2. Medium is an f8. F22 is pretty much the smallest you get on commercial lenses for most SLR cameras. So the f-stop is what we call the aperture settings on your camera. So this is how they're controlled on a film camera. They're most often located on the lens body, on the lens, right next to the body of the camera. So these are common settings for your aperture. Most of them don't go lower than a 1.4, and most of them go up to a 22. Usually you see a 22. So this is the common settings for your aperture. Larger holes have a smaller number. Tinier aperture settings or tinier holes have a higher number. f22 is usually the smallest you get. f2.8 or 1.4 are usually the largest you get on a lens. Okay? These are more common settings, or what it would look like when you're controlling on a digital camera. The AV setting is common for Canon, so it's called aperture value. Remember, TV was for your shutter, AV is for your aperture. So you would look for, because these are called f-stops, you would look for a number that is preceded by the F. So this would be f16. F16 on here. There's the A for aperture setting. And again over here is your aperture with the F number. So when you're setting your menu, your digital menu, you're going to look probably for the F or the A or the AV. Okay, so not only do we control how much light comes in the camera with the aperture, we're also controlling something called depth of field, which controls how much focus you have on your resulting image. So just to give you a quick overview of what that means, with a larger aperture, a smaller f-stop number, a larger aperture, which is a larger hole, you will have less focus, which means that you'll have very little amount of focus in your image. With a smaller aperture, which is a tiny hole, a larger f-stop number, you will have a lot of focus. So think of a landscape where everything's focused. Over here, think of maybe a flower is focused, but everything else is blurred out behind it. Let me show you some examples. Here are the different f-stops and what they look like when the lens is focused at that f-stop. Tiny, f22, large is 1.8. Let's see some of the images and what they would look like. These are student examples again. And here's a chart to show you what it looks like at each f-stop. So again, the lower number, which is the larger hole, gives you the most blur in the background, if that's the easiest way to put it, which I would call the poor depth of field. The higher number, which is the smaller f-stop hole, gives you the greatest depth of field, the most focus. So these images right here would fit down here with the lower aperture number and the larger hole. So these would be down here. These images I would say are probably f2 or f1.4. You can see that they're very carefully focused on their subject, which in these two are flowers or dandelions, and then this one is the baseball. Everything else becomes very blurred behind. To this point where you can't see anything, here it just becomes a blur where you just see colors and shapes. In this one, the lawn just becomes progressively blurry. Okay, let's look again at some mediums. These images here have a little bit more focus, so I would call them medium aperture. They're probably right up in here around the 5.6. This image is probably more like f11, where I can see focus on the bicycle, but as I look back, the cars become blurry, and then I really can't see much. I can kind of guess what's back there. So this is probably f11, where it's pretty focused, but I start to lose focus as I look in the distance. This image here, I'm focused very carefully on the subject, on the portrait. I'd say it's probably a 5.6, but it becomes quickly very blurry and I just see lights and shapes behind her. And lastly, we'll look at these very carefully focused. These are good depth of field images where I can see the foreground, the middle ground, and the background in focus. Foreground, middle ground, and background are carefully in focus. These are probably f22 images here. Okay. All right. So we really haven't talked about the ISO, which is the film speed setting. We will discuss this in more detail, but this is the last setting that you'll see on your camera. Just so that you understand what it is when you're setting your camera, the ISO is something that you will learn more about when we discuss the film unit. You need to know more about your shutter and aperture before you understand ISO. It's a balance of those two settings. So just a quick overview of what ISO is. It's the old-fashioned film sensitivity scale. In a digital camera, you don't use film, but you still need to understand film sensitivity to set your ISO setting. So the quickest, easiest way to explain ISO is that the ISO settings, the lower numbers mean that you're set more sensitive to light. The higher numbers, or less sensitive to light, I said that backwards, sorry. The higher numbers means that you're more sensitive to light. So for example, if I was outside at the beach on a very bright sunny day, I would use a number lower, around a 50 or a 100. If I was inside in a very dark room, I would use a higher number. Okay, that sounds really simple, but what you need to know is that the lower your number, the better your film grain is, the less noise you have. So if you look at this image up here, it gives you a better idea. So instead of just always going for the more sensitive film, you need to always balance it with what your image will look like. So if you think of a photograph that you took on very low light indoors with low light, maybe kind of just a lamp, and it turned out very noisy, that's the term for it, a lot of noise, or we used to call it film grain. It was kind of really purpley or orange and it had a lot of specks on it. That's called film noise. And it didn't look very good and you tried to enlarge it and it has a lot of dots on it. That's why you want to try to avoid using these higher settings if possible. So as we go on with the year and I'm telling you, you need more light, you need better light, you need natural light, this is why. It's better to try to stay down here. So the whole key to photography is having great light. Your images will look better if you're down here. So the more light you have, the better. That's a very simplified version, of course. There's all kinds of ways that you can overcome this light issue. The key to photography is light. Okay, here's some examples of how you would set your ISO setting on your digital screen. This is what that means. So this would be a high, kind of high noisy setting right here. There are times when you have no choice, but you need to use that and you want to get an image in very low light and you don't want to use a flash. This is when you would use this. But there are drawbacks. You get images like this. 400 is usually a pretty good all-around setting. 250, 100, these are great settings where you have very crisp, clear images. Okay, so hopefully that was very informative for you. This is what we have ahead for you. I have planned for you to learn how to use your camera in the next few weeks, how to edit your photos, so very basic edits to make your photos look good. Film, we're going to learn a lot more about film, how to go through the old film process, but also learn about how film and ISO settings work. Then you will learn about shutter and do a motion control project where you do blurred and frozen motion. Your aperture and depth of field where you create a good and poor depth images. And then what's ahead after you get your basics of technical skills down. Later in the semester you will learn about composition and demonstrate the mastery of composition, elements of art, and history of photography. That's what we have in store. So it's going to be a great semester for you. I look forward to all of your great artwork to come.